For each of the following groups, we're going to place the atoms or ions in order of decreasing size, largest to smallest. Let's take a look at A. They're all vanadiums that have electrons being removed. So when you're removing electrons, vanadium has more than 3. It's down here. It's a transition metal. But when you're removing electrons, every electron you remove, the remaining electrons are experience a greater nuclear charge because they get more of the same number of protons to themselves. Not only that, there's less repulsion because you've just gotten rid of an electron, and electrons repel other electrons. So the largest here is the neutral vanadium atom, followed by the one that loses the fewest electrons, which is the 2 positive cation, followed by the 3 positive vanadium, and the smallest by far is going to be the 5 positive vanadium because that one's losing all the electrons in the DNS orbitals. Right, so vanadium's there, it's going to lose those first, and then it's going to lose all of those. So the remaining 18 electrons are going to feel those 23 protons are going to feel more of an attraction to those remaining 23 protons. All right, let's move on to B. These are all group 1 elements that have lost 1 electron. So we have sodium, potassium, rubidium, and cesium. As you go down the periodic table, atoms get larger, and in this case, ions, they're all losing 1 electron, so it also applies. All right, this one's going to end up with 2 energy levels, and this one's going to end up with 3. So, and so on. So just because you have more energy levels of electrons, they're going to shield. They're going to experience more. Those valence electrons down the periodic table are going to experience more shielding. So the largest one is going to be down the periodic table. And then working our way up, they're going to get smaller, with the sodium having 10 electrons, going to have just 2 energy levels full of electrons. Let's go on to C. We have tellurium that is going to gain 2 electrons, and then, so that's going to be isoelectronic with xenon. It's going to have 54. Looks like when you have a mix of cations and anions and cations, that's probably what you can expect. Iodine is right next to it. It's going to gain 1. All right, tellurium gaining 2, iodine gaining 1. So, and then cesium losing 1, barium losing 2. So they're all isoelectronic to each other. In other words, all of these have 54 electrons. So if they all have the same number of electrons, it's going to be the number of protons that determine their size. The more protons you have, the more attraction those 54 electrons are going to feel. So the smaller they're going to be. So let's start with let's just go that way. The one that has the most electrons is the barium, so that's going to be the smallest. And then followed by cesium, followed by iodine. And the one that has the fewest number of electrons is tellurium. So it's going to be the largest. Let's go on to D. This is just the opposite of A, where we had cations, now we have anions. So this time we're not removing electrons, but we're adding electrons. So when you're adding electrons, it has the opposite effect of removing electrons. So they say this is a neutral generic atom. When you add an electron, it's going to increase the repulsion to the electrons that are already there. And not only that, all of those electrons are going to experience less of a nuclear charge because now you have another electron joining the party. So those atoms and ions are going to puff up. All right, let's do this down here. So largest is going to be the one that gained the most electrons. That's going to be the phosphide 3 negative. It's gained 3 electrons, followed by the one that gained 2 electrons, followed by the one that gained 1. And the smallest one is going to be the neutral phosphorus atom. All right, finally, we're off to E. So here we're given all 2 negative, so they're probably all just in the same group. So let's go to oxygen, sulfur, selenium, and tellurium. So again, group periodic trends are easy. As you go down, they get larger. So we'll just go down and up. And oxygen, because it only has 2 energy levels of electrons, it's going to be the oxide anion is going to be the smallest.